Lastly, let's look at the fourth order Runge-Kutta method. Okay, so again, there are an infinite number of versions of this method, and it is the most popular Runge-Kutta method. Okay, so the most commonly used form of this method is y of I plus 1 is equal to y of I plus 1/6 multiplied by k1 plus 2k2 plus 2k3 plus k4 multiplied by our step size h, where k1 is the slope at xi, yi, k2 is the slope at xi plus a half of our step size, and y of I plus a half k1h. K3 is f of xi plus a half h, y of I plus a half k2h. And finally, k4 is the slope value at f of xi plus our step size h, y of I plus k3 multiplied by h. Now remember that the sum of k1 to k4 multiplied by 1/6 gives us our average slope term phi. So perhaps a better way to look at it is with a graphical depiction. So we might have a set of axes, and we are looking at a boundary here, xi, and we want to calculate the value at xi plus 1. Remember, the distance between them is h. So at a midpoint, this is x of I plus a half. Alright, let's just draw this in. Okay, so initially I start out at, let's change color, at xi, and I use the slope here, which is k1, and I find what the slope term is at this point, at x of I plus a half, y of I plus a half k1 times h, and I calculate, so this slope here of k, which is k2. Okay, so I've used k1 to get to this new point where I calculate the slope k2. I then use k2 to get to this next point, which is also x of I plus a half, but the y is different, remember. And so this is k2. Here I calculate the slope value k3, which I then use to calculate, so these two should be parallel. Which I then use to calculate the value of k4 at my x point, which is x of I plus 1 or x of I plus h. I then take the average of all three of these to calculate a new slope phi, which I then use to estimate my next point. So the slope of this line is phi.